Okay, next we're going to talk about how to find the maximum value or minimum values from the derivative of a function. In the previous video, we have found all the maximums and minimums of each graph. Now, if we draw a tangent line at each maximum and minimum, we found that the tangent line is horizontal, right? And we know that when the tangent line is horizontal, that means the derivative is equal to 0. So, for example, the derivative at this point, x1 is 0. The derivative at this point, x2 is 0. The derivative at this point, x3 is 0. The derivative at x4 is 0. At x5 is 0. So it seems like if the derivative is 0, if we have the tangent line is horizontal, then we're going to have either a maximum or minimum. So can we see if the tangent line has a slope of 0, then it's going to be a local maximum or minimum? Now, this is not always true, however. If we take a look at this example, we can see at this point, okay, we have a tangent line, and the slope of that tangent line is 0. However, this is not a maximum or minimum. Okay, so we cannot say that if the tangent line has a slope of 0, then it's going to be a local maximum or minimum. Then what is true? The opposite is true. What is the opposite? The opposite is this. If a function has a local maximum or local minimum at the point x equals c, and if the derivative at x equals c exists, then that derivative is going to be 0. In other words, at a local maximum and minimum, the derivative equals 0 if the derivative exists. So if we go back to here, okay, so because at this point x equals c, at this point x equals c, we have a maximum, okay, and because the derivative exists, so the derivative equals 0. So therefore, the tangent line is horizontal. It seems like here, at x equals c, at x equals c, the function has a local minimum, and because the derivative exists, so the derivative equals 0. Now in this example, the function has a local minimum. The function has a local minimum. However, the derivative does not exist at c, because at c we have we can draw two different tangent line. So this tells us there could be a local maximum or minimum when the derivative are undefined. Okay, there could be a local maximum or minimum when the derivative are undefined. So let's summarize. Let's summarize this. So at the local maximum or local minimum, we have two different possibilities. One possibility is at those maximum and minimum, we have a horizontal tangent line, which means the derivative is zero. The second possibility is at those maximum and minimum, the derivative does not exist, do not exist. Okay. Okay. So next, we look at what is called critical point or critical number. A critical point is an interior point x equals c on the domain of a function at which the derivative is zero or the derivative does not exist. Now, because we know that at maximum or minimum, the derivative is either zero or not exist. So that means if one of these happens, then we may have a local maximum or minimum at there. And if a function has a local maximum or minimum at the point x equals c, then x equals c is a critical point of the function fx. So the local maximum or minimum, they always occur at a critical point. However, not every critical point is a local maximum or minimum. For example, at this point, the example we saw earlier, at this point, since the derivative equals zero, this point is a critical point. But this critical point is not a maximum nor minimum. So when we are looking for the maximum or minimum, we first find all the critical points, and then among those critical points, we search for the maximum and minimum, because the maximum and minimum, they can only occur at those critical points. Okay, so let me do these examples. Find the critical points on the domain of the function. So the first step is to determine what is the domain of this function. Now, because this function is a polynomial function, so the domain is all real numbers. Okay, from negative infinity to positive infinity. Now, in step 2, we're gonna take the derivative of this function, because according to the definition, the critical points are the points where the derivative equals zero or the derivative does not exist. So to find those points, we first need to know what does the derivative look like. So we take the derivative of this function. Okay, so when I take the derivative of this function, we can use a power rule. So this is 3x squared minus 3 over 2 times 2 times x. So the derivative is 3x squared minus 3x. Okay. Okay. Then in step 3, we consider at which point this derivative equals 0. So this is equivalent to solve for this equation. 3x squared minus 3x equals 0. At which x this equals 0. And to solve this equation, we can factor out 3x. So we have 3x times x minus 1 equals 0. So we have 3x equals 0 and x minus 1 equals 0. So x equals 0 and x equals 1 will make this equation be 0. Therefore, the critical points are 0 and 1. Here the reason we don't consider the points where the derivative does not exist, because the derivative is also a polynomial, so it exists everywhere. So that's why we don't have to consider that.